Hi students, so welcome to our channel. In this lecture, we are going to learn about abstract data types. In our previous class, we learned about introduction to data structure. In that lecture, we discussed about what is data structure and types of data structures. So, overview of today's presentation is, so first we are going to learn about the definition of ADT. So definition of ADT. After that we learn about what are the benefits we have, so because of abstract data type, and we discuss ADT with one example. Okay. So outcome of this lecture is, so understanding of what ADTs are and their purpose. So what is the purpose of ADT, and we learn about how to implement ADT in C. Okay, these are the outcomes of this class. Abstract data type. An abstract data type is a data type that is defined by its behavior and operations rather than its implementation details. So what it is? Here we are going to design one abstract data type. This ADT defines the behavior and operations rather than its implementation. That means the user does not know the implementation of the data type, but they are going to use the data type. So that is an abstract data type. The abstract name itself indicating that abstract means hiding. So what we are hiding means we are hiding the implementation details. Okay. So simply saying what is abstract data type? So abstract data type is defined by its behavior and operations and hide the implementation of the data type. It provides a logical representation of data structure and set of operations to manipulate that structure. The implementation of data type is hidden from the user. That is the abstract data type. You are going to hide the implementation of this data type and allowing them to use the ADT without knowing the implementation. Okay. So for example, stack queue. So these are the data structures we are going to define as stack ADT and queue ADT. Okay. And ADT tells what is to be done. So what is to be done, and data structures tells how is to be done. So for example, in future classes we are going to learn about stack data structure and queue data structure. Now we are going to implement this stack ADT using array, or we are going to implement the same stack using linked list, Now the ADT tells what is to be done. That means the stack have some properties that we call as a stack ADT. Now we are going to implement this stack using either array or linked list data structures. And ADT gives the blueprint and data structure provides implementation part. Okay, I hope you all are understand the definition of abstract data type. So ADT means it's a data type that is defined by its behavior and operations and hide the implementation. The ADT tells what is to be done and data structures tells how is to be done. In C, ADTs are typically implemented using structures and functions. Okay, structure means so different types of data types we combined as one structure, and functions means the different operations you are going to perform. The structure represents abstract data types, internal state, and the functions provides the operations to interact with the data type. So for example, if you create one student structure, the structures contains number, name, let us assume. Now, so these number and name can be accessed using some functions. Those functions we call as a operations. Now, the header file defines the interface, that is a function prototype that can be used by other parts of the program, while the actual implementation resides in a separate source file. The abstract data type means the data type and functions. These functions we call as a operations. So these operation implementation we store in one separate source file. Now, so this separate source file can be accessed with the help of one interface. So by using this interface, the application program will access or uses this abstract data type. Now you understand. So this is the graphical representation of ADT. So this is the abstract data type. Now all the data types, that means in C we are going to implement using structures. Now this structure and operations, that means functions. So these are included in one file. So now this is the ADT. Now we write another program. So this is the application program. Now from this program we are going to access this abstract data type through this interface. Now if you observe that hash include stdio.h. Now this stdio.h is a header file. So that is the interface we are going to use the functions in the standard input output header file. Okay. So now similarly, so this application program, if you write one program, that is the application program. In this program you are going to access one abstract data type using the interface, that is we call as a header file. Now you understand the third point. The header file defines the interface. stdio.h is an interface that can be used by other parts of the program. So this application program will access the header file through the interface stdio.h. Okay. So benefits of abstract data types. Abstract data types promote code modularity and reusability, as the internal implementation details are hidden from the user. We all are write the C programs. In every C program we write hash include stdio.h. Now, so this stdio.h is a header file we are going to reuse in your programs. So this header file we use in different modules. Okay, so that is the benefit of abstract data type. So abstract data type promotes the code modularity and reusability. They simplify code maintenance, as changes to the internal representation can be done without affecting the user code. What it means? So for example, if I want to change anything in this stdio.h, then we are going to modify this header file. We don't modify anything in the application program. Okay, so that is the advantage of abstract data type. And ADTs enhance code readability and comprehensions by providing clear and concise interfaces. So now we discuss abstract data type with the help of one example. In this example, we are going to define a date abstract data type. That means we are going to define one abstract data type. The abstract data type name is date. Okay. So now, so for example, the date 7/8/23. Now, in this, the 7 represents day, 8 represents month, 23 represents year. Okay. Now we are going to create one abstract data type. The abstract data type name is date. Now in this, the data type is, the first one is integer, second one is integer, that means the day is an integer, this is the integer, month is the integer, year is the integer. Now, so what is abstract data type? In C, we implement the abstract data type using structures. Now, this is the struct date. Now, this date contains three parts. One is day, another one is month, another one is year. Okay. The day is integer, month is integer, year is integer. Okay. So, now, so this is the structure, and abstract data type is a structure, that means a data type and functions. That is the operations. Now, so these are the operations. Here first one, a date represents a date in a calendar. Now, this is the date. Okay. Second, so these are the operations. So, first one is create date. If you give the input 7/8/23, now it creates one date. The first argument is considered as a day, second argument is considered as month, third one is considered as a year. Now, this function creates date function creates a date. Now, get day, this function returns day in the date. That means if you give the input 7/8/23, now it returns 7 as output. Get month returns month in the date. Now it returns 8 as output. Get year date, it returns year in the date, that is 23. For all these functions, we are going to give the input is date here. Okay. Now we see the program. So first we create one interface, the header file defining the interface. So this is the interface. So here we have one structure known as a date. So this represents the structure name, the structure struct date. So this we are going to implement in actual file, that is another file, that is a source file. Okay. So now this date.header file contains four functions. One is so create date, the arguments are day, month, year. Similarly, so get day, the input is date. Get month, the input is date. Get year, the input is date. Now this is the interface. Okay. Next, source file defining the implementation. Now in previous slide, so these are the structure date and these are the functions. Now date is a data type and these are the functions, operations. Now we are going to implement, we are going to define these data type and functions. Now this is the source file defining the implementation. Okay. So now in this we include the date.h. Now this date.h contains date as a structure and there are different functions. One is create data, get month and get year. So now the struct date contains three parts. One is day, month, year, all are integer. So now create date, whenever we call this function, it create one structure, the structure name is date and assign the day, month, year to the elements in the structure. So here we write date arrow day equals to day. So day arrow month equals to month. So day arrow year equals to year. So for example, if I pass so 7, 8, 20, 23. Now this is the 7 is assigned to day. Now this day is assigned to day here, that is a structure. Okay. So these two are the different variables. So this day is a local variable and this day.day is a variable in structure. Okay. After creation of date, it returns the date here. Okay. Now another function get day. So get day means it returns date arrow day. So now it returns a 7 as output. Next, get month, it returns date arrow month. Get year, it returns so date arrow year. Okay, so this is the implementation part. So first one is interface, second part is you are going to implement the abstract data type, that is a date here in this scenario. Now the actual program, that is the application program. Now in this program I am going to include this header file date.h. Now I call so struct date create date. Now create date, if you observe that the create date function implementation not in this program, so that is in implementation program. Okay, here create date 7/8/2023. Now so this is the date is created with the help of by calling this function create data, so that is resides in another program. Now you understand the definition of abstract data type. So what is the abstract data type? It's a data type and operations and hiding the implementation from application program. Here this is the application program. Here actually we are creating the date with the argument 7/8/2023, but here there is no implementation. The implementation is hide from the application program. Okay, similarly, so print date get day of date. Now there is no implementation. The implementation in the source program that we access with the help of date.h. Okay, so get data means it returns 7, get month means 8, get year means 2023. Okay, the abstract data type contains 3 parts. One is interface, second one is implementation source file that we call as a source file, and third is application program. Now we come back to first slide. So come to this diagram. In this diagram the application program is date adt.c. The interface is date.h. The abstract data type is date.c. Okay, the source program. The source program is date.c, that is the abstract data type. We implement in date.c, so that we access with the help of date.h, that is a header file, that is the interface we include in application program, that is date adt.c. Okay, so this is the date.h. So this is the date.c. Now this is the date add.c. Okay, so in this program we include date.h. This is the interface. By using this interface we are going to access the so date.c that contains structure and different functions. Okay, so summary of today's lecture. ADTs are a concept in computer science that allows the definition of data structure along with the operations that can be performed on that. Okay, in our previous program the date contains the data type and the operations. Okay, we are going to utilize the operations by using this ADT. So ADT promote code modularity and reusability. Okay, as the internal implementation details are hidden from the user. So ADTs are implemented in C using structures to represent the data and functions to perform operations on the data. In our example, the structure represents the data, means the date is a structure, contains day, month, year, and the functions to perform operations means the functions are create date, get day, get month and get year. Okay, I hope you all are understand what is abstract data type and what is the purpose of abstract data type and how to implement abstract data types in C. In next class we are going to learn about stacks. If anybody have any doubts, so place your doubts in the comment section. I will answer all the comments. So thank you.